Hello everyone, my name is Viraj and today we'll be looking at the 12th problem from the CP-31 sheet by TLE Eliminators under the 1000 rated problems. Let's go. So move down to my sheet over here, ticked off 1000 and I'll go to my 12th problem, beautiful array. Let's read this. Stanley defines the beauty of an array of length n which contains non-negative integers as follows. So summation from I equals to 1 to n, ai by k, and then there is a floor division to it. I hope you understand what that means. We'll of course discuss that, which means that we divide each element by k, round it down, and then sum up the resulting values. Very simple. Stanley told Sam the integer k, and he asked him to find an array A of n negative integers such that the beauty is equal to b and the sum of these elements is equal to s. Help Sam find any arrays that satisfy the condition above, and for each test case, print -1 also if such an array does not exist. That means there is an impossible case also in this. Okay, very simple. Let us quickly discuss this problem. So I'll be given 4 values in this problem. I have been given n, I'll be given k, I'll be given b, and I'll be given s. Now what do I want to output? My output is actually an array. My output is an array. Now where these variables come into picture? N represents the size of this array. Okay, size of the array above that I'm trying to print. So if n is given 5, for example, then I'm trying to print an array of 5 size. Now what is k, what is b, and what is s? Everything is interconnected. When I actually print this array, my target is when I take the summation from I equals to 1 to n, for every element, let's say ai, upon this k value, round it down, then this should be equal to b, and the summation of all the values itself, that is simply ai, should be equal to s, or basically sum of the array should be s. I have actually drawn a small illustration in front of you. Assuming that n is 5, that means I'm basically looking for 5 elements which sum up to give s, and if I divide every element by k and sum it up, it should give me b. This is called beauty, this is called sum, this is the size, these are the elements, and this is this k variable. So n is given, s is given, b is given, k is given. You have to print such an array that satisfies these conditions. If you can, great, print it ahead. But they have also said that there can be a -1 case also. So it means it's not always possible. It might be impossible under these conditions to create such an array. So print a -1 instead. So let's talk about the 4th test case. 5, 4, 7, 38. N is 5, k is 4, b is 7, and s is 38. Now in this case, they have said that I can print an array that looks like 0, 3, 3, 3, 29. Let's print that. 0, 3, 3, 3, 29. Now why is this right? Of course, these are 5 elements. So n5 is checked out. Let's see the other conditions. If I divide all of them by 4 right now, that is the k value. So by 4, by 4, by 4, and I add everything up. So I know that when I am looking for division by k, I'm looking for a floor-based division. Okay. Now a floor-based division, of course, means that I'm removing all the decimal part that comes up and I'm only bothered with the integer part. That means this value is basically 0 by 4, 0. This is like 3 by 4, that is 0 point something, but you will again consider this as 0. This is 0, this is 0, and 29 by 4 will be 7 point something, but that is again 7. So this is 0, 0, 0, 0, and 7, which means this actually turns out to be simply 7. Now see, the beauty is 7, and yes, I got 7. Good to go. Now what about the sum of the elements themselves? 0 plus 3 plus 3 plus 3 plus 29. This is basically 9 plus 29, which is 38. So this is good to go? Yes. Okay, so this is the test case explanation. You can again pause the video and go through the other cases also. I just discussed one case, and maybe you can try to come up with an idea where you can actually see why is it -1, and if not, why is the answer that they have proposed checking out. Let us now move on towards our expected time complexity. So we know for a fact that in this case, one test allows me 1 second, that is like 10 power 8 operations. And then it's given that there are some test cases, but it's written very neatly that sum of n over all test cases do not exceed 10 raised to 5 order. This means that I don't need to worry about these test cases anymore. I can directly compare with n with one test itself. So I'll write it like this. One test is equal to 10 raised to 8 operations. And n is given in, you can say 10 raised to 5 order. So I can create a linear solution. I can even create a little higher n log n solution. I can even create something that is like n square root n. That's also fine, good to go. But if I go a little larger, something like n square, that's a problem. I cannot create n square. Now, if I come down right up till constant solutions, all of this is good to go. So all of these solutions are sort of promoted, but this is something I don't want to work with. This is my expected time complexity, which is again now helping me tell that, okay, don't go for brute solutions in like square order, remain in linear or a little larger only. And if you go anything down, that's also fine. Great. Now let us move on to the explanation of the problem. Let's say that n is 2, k is 5, b is 2, and s right now I have not defined. I'm trying to actually see a small observation on s. Follow this up with me. Now n being 2, that means you're looking for 2 elements. Now see this very carefully. Let's say I place the first element as 5 and the second element as 5 also. Now 5 by 5, that is by k, will automatically give me, you can say, 2. You can observe that the sum right now will be 10. But let's say that one of these elements is actually not 5, but let's say it's 7. Now 7 by 5 is 1 point something, but you still consider that to be 1 because you're looking for a floor division. And 5 by 5 is still 1. So do you think the beauty has changed? The beauty of the array still remains 2. But if you observe s has gone to be 12 because 7 plus 5. Now let's say both of these elements actually become 9. Now 9 by 5 will be 1 point something, but again you consider that to be 1. 9 by 5 again will be 1 point something, again 1. So beauty is still 1 plus 1, 2. But the sum has gone to 18. Interesting. Let's do one thing. Let's say that 9 becomes 10 over here. Oh, not possible now. Because as soon as this happens, 10 by 5 is 2 now. So the beauty has changed. So now the sum has become 19, which is not possible. Not possible in terms of saying that the beauty has now changed. So this sum will not make sense. Now let's reiterate on our story. Let's go a little back and say that how about these elements would have been 4 and 5. Now in this case, you can see that 4 by 5 will be 0 point something and 5 by 5 will be 1. So your beauty will actually turn out to be 1. And the sum actually turns out to be 9. Now, had this value 4 been just 5, then the beauty would have been 2 and the sum would have worked out to be 10. This is actually what we started off with. Now, this whole story is over. What did you observe? If I write on the number line like this, like let's say 1, 2, 3, 4, so on. Let's say this extends to infinity. If I actually want to write the value of s, do you think it's a constant value? We saw that beauty equals to 2 could have been still maintained and s was changing. S for 9 or up till 9 will not work out. S 19 or 19 onwards will also not work out. But we actually saw that 10 to 18, this range of s was actually in which we could have still maintained a beauty of 2. This means that if we talk about some particular beauty B, then for a fixed beauty, the S value can range from some low point to some high point. For a fixed B value, S has a min and max range under which it satisfies the case. And this is our main idea in the problem. Because this range is present on S, that is why if you think the problem also says that there is a -1 case. Because if S cannot take a value from 0 to 9 or 19, 19 onwards, then don't you think had in the problem already something like let's say 20 was given as S, you would have directly printed -1, right? Because you just saw that S can only belong to 10 to 18. If S was given, let's say 5, for example, then also you would have said, oh, this is a -1 case because I know anything from 0 to 9 is not possible. So the impossible thing makes sense. Now by that argument, what is left for me to do is generalize this now. I took an example, but maybe we want to talk in variables. What is the least S I can make and what is the largest S I can make for some given n, k and some b value? Let's say that I'm talking about random 5 numbers. There is some k value given to me and some b value given to me. So basically I am looking for 5 places to fill right now. Now let's first talk about minimizing S. How low can S go? I'll give you an idea. Because S is the sum of all the elements in the array, it makes sense that there should be elements which are mostly 0 because 0 will not add anything to your sum. So how about this? Let's do a clever thing. Let's say that you have 4 zeros in the array And the first element, for example, or any element for that purpose, let's just focus on the first, I'll keep that element to be k into b. Now with this, I am actually finding the minimum s, which is satisfying the b value. Why? Because if you try to find the beauty of this array, you will divide k over here, k over here, k over here, k over here, and k over here. Now all these four elements will give you 0 because 0 by k is still 0. But k into b by k will cancel out, and this gives you b. That means the beauty of this array actually turns out to be b. And you can say s turns out to be k into b. And think, according to me, I am saying that the minimum s that I can achieve, which satisfies for some n, k, and b, is actually k into b. I hope this should make sense. This is actually right. And this is basically greedy. I have made sure that n minus 1 elements were all 0 because I don't want my sum to increase a lot. And just one element, I made sure that it is the lowest possible value, which ends up giving me b as a beauty. All the other elements were giving 0 contribution. This single guy, if divides by k, gives me b as a beauty. B number is only given to me back. That means the beauty turns out to be b. And when I sum this up, I cannot do anything better than this. Every element is 0. If you go a little lesser than k into b, you will actually not end up creating a beauty of b. So this means minimum s actually works out. Okay, idea number 1, done and dusted. I had to find the minimum s. Yes, I found that. Let's talk about idea number 2. Now, what's the highest s you can make so that your beauty of the array is still b? So let's try to build on top of our previous idea. You had k into b over here. You had a 0, 0, 0, and 0. Now your beauty is b of these elements. You know this. Now you're not trying to harm the beauty. You're just trying to increase the sum but keep the beauty same. How do I do that? Let's, for example, say that k was 3. Now if k was 3 and had this value been 1 instead of 0, do you think 1 by 3 would have still contributed anything larger than 0? Initially it was 0 by 3, that is 0. Now 1 by 3 is still 0 point something, but you will consider that to be 0. Now next time, let's say this value would have been 2. 2 by 3 is still 0 point. So you would have still considered that to be 0. So there is no contribution from here. But as soon as this value would have actually become 3, oh no, 3 by 3 would have actually become 1 now. So now rounding 1 will automatically be 1. So the beauty has increased. Can you see a small idea from here? Actually, the small idea from here is that if I want my sum to now go up without harming the beauty, the max case can be I start placing k minus 1, k minus 1, k minus 1, k minus 1, and a k minus 1 at this location. Basically, k minus 1 at all the 5 locations. See, k minus 1 by k will give you some value that is 0 point something. Now 0 point something will automatically convert to 0. So all the contribution to the beauty that comes from all these 4 values will still remain 0. And what about this term? If it's k into b plus k minus 1, if you do a by k over here, then you can say that this fraction can be distributed into writing k into b by k plus k minus 1 by k. Now same logic, k into b by k will be b exactly, plus this value will be 0 point something. Now when you add 0 plus some decimal part more, it will become something like, if b is an integer, point something more in decimal. But again, you know, it has to be rounded down. So it will not be considered. So this actually still gives you b. That means adding k minus 1 even to the first term is not changing the contribution from that term, that is still b. So the beauty of this array still remains b, but the sum has actually drastically increased. By how much? Your sum has now become k into b plus n into k minus 1. Fairly obvious, you are adding k minus 1 value n times. And now greedily, this is actually the largest s you can make. Because as soon as you increase any of these terms, you will actually end up making beauty a little higher than its current b value. That means this is the largest I can go. Greedily, my idea number 2 says this is actually the maximum. Now, if you have actually understood this idea, I can quickly show you the demonstration on the last case that we discussed. If you actually plug in these values over here, you will actually end up getting this 10 to 18 range. How? See, min s formula according to me is simply k into b. K is 5, b is 2. So k into b is 10. And max s formula according to me is, you can say, k into b plus n into k minus 1. So k into b is 10 plus n, that is 2, into k minus 1 is 4, that is 8. So this gives me 18. Voila, 10 to 18. See, the range worked out? Yes, it worked out. So all of this actually now makes sense. I have actually found very nicely my minimum and my maximum S range. Now, if I have this, I know I have tackled the -1 case, because if min and max is sorted for me, I can just check with the S that is given to me in the problem. It's a constant value. If it falls in that range, I know I can maybe make something, but if it doesn't fall in the range, then I know it's a straight -1. So I can write that K into B is less than equal to the given S is less than equal to K into B plus N into K minus 1. Okay. Now you will say, sir, I think the problem of -1 has been handled, but we still don't have any idea that what if S actually falls in this range? How do we create an answer? Now from here on, this is all implementation. What I can do is, very smartly, start off with my minimum case. I can create an array that looks like K into B, first term, let's say, and all the other terms are, let's say, for example, 0. Let's say there are 5 terms, all the other terms are 0. Now what is the current sum of this array? It is K into B. So the given S value that is there, from that I can remove K into B. Let's say this becomes S dash. Now my target is somehow this array should have the sum more so that it is able to cover this difference of S dash. For that, what I can do is, I know for a fact that in one element, the maximum change that I can bring is K minus 1. Like I can add maximum K minus 1 to each and every element. So what I can do is, I can have a simple for loop where I can now move on to the first element to the last element. Every place I can try to add K minus 1 and see, is my still S dash value left or not? If it is, then I can add K minus 1 value to that particular place and decrease S dash by K minus 1. Next time I can move on to my next element and I can say, okay, is K minus 1 still available for me to remove? If it would be, then again this will go down and I will place a K minus 1 at this location. And I'll keep on doing this till I reach the end. Now, because I know that the S value that I've just calculated is within the range, an answer is possible. So it will happen that somewhere in the middle of these iterations, S dash will get exhausted, or I reach the very end and every element has been increased by K minus 1. Let's actually see this idea in motion. Let's talk about that fourth case. Okay, so you want 5 places to fill. What you can do is, the first place can simply be K into B. So I'll place 28 over here. Okay, and now all the other places are right now 0. Now the sum of this array is actually 28. The beauty is 7. You know that for sure. Now beauty has to remain constant. Only sum has to go up. How much more sum do you want to make? 38 is what you want to make. 28 is something you've already made. So you want to make 10 more as a value. At a single point, what is the maximum value can you add? K minus 1. Now K is 4. So I can maximum add 3 on a single place. So what I'll do is, I'll add 3 first over here. When I do this, my 10 value will come down by 3. It will become 7. Oh, it's still positive. I have still more to go. Let's move on to the next case. This becomes 3. Again, I'll decrease this. This becomes 4. Still more to go. Okay, let's go to the next value. This becomes 3. And now this becomes 1. Now the fourth value, I cannot actually make it 3 anymore because I only have one sum left to cover. So I'll just make this 1. This becomes 0 and I can break from this point. That means now my final array actually looks something like this. 31, 3, 3, 1 and 0. And this is actually a valid array. Let's see. 31 plus 3 plus 3 plus 1 will actually give you a 38 sum. Pause the video, check this out. I think that's true. And if you do 31 by 4, 3 by 4, 3 by 4, 1 by 4 and 0 by 4 and add it up, you will actually get 7. Okay, so it's very, very easy from here on. The main idea in this problem was just to crack the min and max S. And after you actually crack that, just by following this idea of adding K minus 1, K minus 1, K minus 1 every time on the starter array, you can say, is what we can do to create an array which satisfies the S value, because B was already satisfied. We know that for sure. So we're just looking to satisfy S. Okay. Similarly, all the other cases will also check out if you pause the video and solve this problem. I hope this makes sense. Very, very fun problem. Definitely involves mathematics and a greedy idea. Now we can look at the coding part and see my implementation in picture. Again, there can be 10 different methods to implement this out. The crude idea should remain same. You have a range on S, so make sure you check that. So what I'll do, I have these test case variable. Now I have N, K, B and S. I'll take all the input. Now what is the minimum S I can make? K into B. What's the maximum S I can make? K into B plus K minus 1 into N. If S is less than that or greater than that, it's a -1 case. Else, I know a case is possible. What will that case look like? I have this answer vector. The first element will be the min S, that is K into B. From S, I will remove that value. Now I'll run a loop starting from the 0th index. And how much can I add on the current element? Either it's k minus 1 or it's s. Whatever is the minimum out of that, I'll add that to the answer of I, and from s, subtract that much. So after a point of time, if s starts getting exhausted or s is lower than k minus 1, then s will only get added. And when you come out of this array, you know that this answer vector is absolutely made in such a way that yes, it is going to follow everything for me. Okay, now what do you think is the time complexity? Very, very simple. All of this is pretty much constant. This is a simple n loop that I'm running, and an n loop I'm running over here to print that array. So I know that I have actually come up with a time complexity that is O of n. Now O of n was something that was expected also. So this is like writing 10 raised to 5 order. And what about the space complexity? Space complexity is also 10 raised to 5. Now mind this is actually with respect to a test, not a test case. Okay. And this is where we can end the problem. Very fine, very mathematically greedy idea. I hope you like it. Thank you for watching.